Complex resistor combinations part 2. In this situation, or in this video, we're going to look at both series and parallel resistor combinations in combination. And what we're going to be, the strategy we're going to use is we're going to redraw the circuit as a line rather than a loop. And we're going to find equivalent resistances of each part. And basically we're gonna pull it all down so that it's like one resistor. So I'm gonna jump right in to this example, and I think the steps will make more sense after you see the example. Example 1. Find the voltage and current across each resistor. A 10 ohm resistor is connected in series with two 30 ohm resistors that are connected in parallel. The whole thing is plugged into a household outlet. Okay, so R1 is 10 ohms, and then I've got two in parallel, R2 and R3. They're both, 30 ohms. And household voltage is typically about 120 volts. So over here, I'm going to use my same strategy of making a table. And my three variables in the table are, one moment. My three variables are resistance, current, and voltage. And I mean, at this point, I think we know what the units are, but I'll just put them there. So resistor number 1 is 10, and these two are 30 ohms. Okay, so what we're doing here is we're kind of imagining that we're taking these two terminals and unclipping them and putting this in one line. And the first thing I'm going to do is oh goodness, let's get the highlighter, not the eraser. The first thing I'm going to do is combine the two in parallel. So to combine resistors in parallel, I'm going to say 1 over the equivalent resistance is equal to 1 over 30 plus 1 over 30. Now you could get out your calculator to do that, or you might know that that's 2 over 30. And then if you take the reciprocal of that, the equivalent resistance would be 15 ohms. So I've just replaced those two 30 ohm resistors with an equivalent 15 ohm resistor. And then of course I still have, I still have a 10 ohm resistor. Okay, once I do that, now I just add the series resistors together. So 10 plus 15 would be 25 ohms. And I've got essentially, let me back up a little bit here. This 120 volts is across this whole resistor. So now I'm going to work backwards through the steps. I've got voltage and resistance, and I can solve for current. 120 equals I times 25. So the current is 4.8 amps. Okay, now I'm going to take that back step. 4.8 amps flows through both of these series resistors. Now, for the 10 ohm resistor, I've got 4.8 amps flowing through it, and I know V equals I times R, so I just need to multiply to get that the voltage here is 48 volts. So I've got 48 volts across that 10 ohm resistor. Now, a couple things. One is I know that the total voltage is 120, so I could take 120 minus 48 to get 72 volts. Or I could take 15 ohms times 4.8 amps to also get 72 volts. Regardless, there's 72 volts across that resistor, and therefore there's 72 volts across this 30 ohm resistor combination. And once I figure that out, again, I can use V equals IR. I can divide to get the current. And 72 divided by 30 is 2.4. And this should not be a surprise either, because what I just found is that I've got 4.8 amps traveling, and then it splits in half. So I'll make narrower pictures here. So that 4.8 amps splits into 2.4 amps and 2.4 amps, and then when it gets back to this terminal, it comes back together, and we're back to 4.8 amps. All right, let's try example 2. One of the 30 ohm resistors is changed to a 6 ohm resistor. Now this is a little trickier because the current's not going to split evenly. So let's draw this. We've got 120 volts. Let's see, 10 ohms, 30 ohms, 6 ohms. And I'll come back over here, make my handy table. Okay, so I'll draw this out. So again, same idea. My first task is to combine the 30 ohm and the 6 ohm resistor. Just like up here, we combine the two 30s, now the 30 and the 6. So I'm going to use the same formula for resistors in parallel, reciprocals. Again, you could use a calculator or you could use fractions. So the equivalent resistance is going to be 30 divided by 6, or 5 ohms. So now when I draw my next set, I've got 10 ohms. Oh, my handwriting is really going downhill. 10 ohms and 5 ohms. And when I combine those together, I get 15 ohms. Now, once again, I'm going to work backwards. So 120 volts across the whole thing. 120 volts equals I times 15 ohms. And I'm going to divide. So that's 8 amps. I go back a step. Okay, so we figured out 8 amps is flowing through there. 8 amps is flowing through here. If I use V equals IR, if I take 8 amps times 5 ohms, that's going to give me 40 volts here. And 8 times 10 is going to give me 80 volts here. Notice the 40 and the 80 add up to 120. That's a good thing. Let's see. So I've got, for the 10 ohm resistor, I've got my 80 volts. I can divide to say that's going to be 8 amps. Got 40 volts across each of the remaining resistors, and I can divide. 40 over 6 would be 20 over 3, or you could put it as a decimal. And 40 over 30 would be 4/3. Notice that 20 thirds plus 4/3 is 24/3, which adds